Hi everyone! While I'm having fun getting a root canal today, you'll be having fun solving trig equations. For today, the domain you'll be solving on is 0 degrees is less than or equal to theta is less than or equal to 360 degrees, or one rotation in the positive direction around the unit circle. So let's go ahead and get started. We'll start with some simple problems first. Okay, so here's our first equation. We're going to solve cosine theta equals negative 0.42, which means I'm looking for angles theta in this domain, which tells us we're working in degrees. Make sure your calculator is in the correct mode right now. We want angles theta that are going to give us a negative ratio of 0.42. Okay, not a friendly ratio from our trig table, so we'll definitely be using our calculator. So you guys know that since there's really nothing to simplify in this equation, we can go ahead and cosine inverse both sides immediately, and I'm going to do a little shortcut here. I'm just going to show isolating theta because you know when you cosine inverse a cosine, those two things cancel out. So theta is equal to cosine inverse of the ratio negative 0.42. Now, before we pick up our calculators and figure out what we're getting as our answer, we should really think about what quadrants our angles are coming from. According to All Students Take Calculus, these are the quadrants where the ratios are positive. So positive ratios for cosine are going to be in the first and fourth quadrants. And since our ratio here is negative, that means we're going to get our angles from quadrant 2 and quadrant 4. So go ahead and do the cosine inverse of that ratio with your calculator, and we should all be getting an angle of 114.8 degrees, which is already in quadrant 2, as it should be, because that was the rule we saw when we looked at inverse functions. If we were taking the cosine inverse of a negative ratio, then we should have gotten an angle in quadrant 2. Now, this is what's happening here with that angle. You found the angle 114.8 degrees coming around from the positive x-axis. But what we're really going to need then to work into the third quadrant is we're going to need this reference angle. So to find the reference angle, we're going to make our half a rotation, 180 degrees, and we're going to subtract the angle that we just found, 114.8 degrees, from it, and that's going to give us a reference angle of 65.2 degrees. So that angle, 65.2 degrees, will now help us find our angle in quadrant 3. And we can find that angle by taking 180 degrees and adding that reference angle, 65.2, to it. And that's going to give us an angle of 245.2 degrees. So our solution set, since we have more than one answer for theta, we're going to write it in set notation using curly brackets, is 114.8 degrees and 245.2 degrees. And there we go. Now, what I really want you guys to kind of be thinking of and linking these things together is what's really happening graphically also. So if we take a look at one period, because that's what our domain is showing us. If we look at one period here of our cosine function from 0 to 2 pi, you guys remember that it starts up here at the maximum, goes to the midline, minimum, midline, and maximum. And here's my cosine curve. And what we were really finding were the points of intersection here where the ratio was equal to that ratio of negative 0.42. So we see 2 points of intersection where these two functions intersect. And if we look, we are getting two angles in two different quadrants. This one represents the second quadrant here because it's in between pi over 2 and pi. And this one over here represents our angle from quadrant 3 because that point of intersection leads us to an angle between pi and 3 pi over 2. Hopefully that makes sense to you guys.